2.5, scatterplot and linear regression. We're going to talk about scatterplots and what they mean, how useful they are, and then we're going to talk about what line regression is and how super helpful that is. First, let's talk about scatterplots. It's a set of data whose two variables graph as normed pair. What that means is you can get data on something, like they have here, the number of visitors to Isle Royale National Park. You can see, okay, in 1992 there was about 22,000 visitors. In 2000 there was about 21,000, and so on. It's just a way to place your data. And you can do it of anything. You could do it for, let's say, how long it takes to get to school, or let's say how far you are from school in miles, to how long it takes to get to school time. In that case, you'd see something where the closer you live from school, if you live down the block, it would take you hardly any time. But if you go a little further, maybe you walk to school, so it takes a little longer. Maybe you bike, something's kind of like this. But you might notice as far as you live out, it could take you forever to get to school. You can get a scatterplot looks like that. Some people drive slower, some people faster. But in general, you can get something that looks kind of like that. And that's what scatterplots do. They give you information that talk about two things, and really how they correlate. So there's difference of correlation. There's a positive correlation, which just means that as x goes up, y also increases. As this goes further out, that goes higher. As you saw right here with our timer, the further you live from school, the longer it takes you to get to school. It's called a positive correlation. And there's stuff like a negative correlation. Sadly, this national park right here, you can kind of see it's kind of a negative correlation. The further out we get, the less people are going to national park. Support national park people. And there's something we call a no correlation. That means they have nothing to do with each other. So a good example of that would be, let's go back to our how far you live from school. It's about how far you live from school to your GPA. In that case, it doesn't matter. You might have kids that live really close to school that have really high GPAs or low GPAs. There's no correlation to that. That's something that has no correlation. It's a random occurrence. That's correlation. When it's going up, it's positive correlation. As one gets higher, the other one gets higher. And then there's negative correlation. As x gets higher, and then y gets shorter. And eventually we're going to talk about strong and weak correlation. And that's about how clustered the dots are together. You might get some that are clustered really close together, like a straight line, strong correlation. And you might get some that look like these where it's kind of going down, but it's not like it's super obvious. Strong correlation, weak correlation. The next, see these little lines here? It's called a line of best fit. A lot of times when we have a correlation, we try to find a line of best fit. That's just a line that kind of goes through most of the data. You're trying to get through the middle of the data. You're not trying to really hit anything, you're just trying to get through the middle as best you can. That's what they're doing here. Okay, trying to get through the middle. That's a line that best fits. It's trying to get good approximation of the data. There's no one right answer for that, you're just trying to draw a line kind of middle. Why is that line important? Well, if we have a line, we can start predicting stuff. We can write an equation for that. If we have a line, then we can do a prediction equation. If you have a prediction equation, you can start predicting stuff. You could be over here, you could go. If we're looking at the park service, you're like, oh, in 2016, how many people are going to be at the park? That's why a prediction equation is so important. That's why line of best fit is important. Let's talk about how we're going to do that. Let's say we have our correlation data. We're going to draw a line of best fit. You're just trying to get the middle of all the points. You're not trying to hit anything. You're just trying to get through the middle. And then how do I do a prediction equation? We do any equation. Y minus y1 equals m times x minus x1. That's how you find the equation of a line. On this prediction equation, you can find 2 points that cross nicely, like we always do. Find the slope, plug a point in, and we get our prediction equation. That's how it's going to work. So let's do an example here. The table shows the temperature in the ocean at various depths. If you're right at sea level, it's about 22 degrees Celsius. If you go down 300 meters, it's pretty far. You're at 20 degrees Celsius, and then so on. It gets really cold. Make a scatterplot of a line of fit and describe the correlation. What we're going to do here, I'm going to pause for a second and write this all up. I'm just going to plot it, 0 to 22. At sea level, I'm at 22 degrees Celsius. And then at 300, I'm at 20. And then at 500 meters, I'm at 13 degrees. 500, 13, that was a big jump. And then at 1,000, I'm at 7. 1,000, 7, around here. And then at 2,000, I'm at 6. All over here, I'm at 6. I did my scatter plot. Check that off. Let's do a line of best fit. Here's a very important thing with line of best fit. No right answer. Just trying to draw a line. The idea is you're not trying to get a line that hits the most points. You're just trying to get a line that's in the middle of most points. What's the same distance away from everything. I'm going to do like this. I'm just trying to make a line that cuts through stuff. That's my line of best fit. It would be nice if it's actually straight, but whatever. Describe the correlation. Look at your line. It's going down. It's a negative correlation. So use two-order pairs to write a prediction equation. Next, we got to find two-order pairs. Hopefully, something happens when you draw your prediction lines. You have two places that cross nicely. For me, I'm going to say cross nicely right there. And then look for a place where it crosses. Oh, right here. Let me use those 2 points. I'm going to have 218. And over here, I have 1,012. And those are just estimates. It all depends how you draw your line of best fit. But you want to hit two places that cross nicely. That's the goal. Now that my 2 points, let's write a prediction equation. We always do. y minus y1 equals m x minus x1. I gotta find my slope. Let's find the slope. y2 minus y1 over x2 minus x1. Here's, let's say, x1, y1, x2, y2. I'm going to have 12 minus 18 over 1000 minus 200. I get negative 6 over 800. Let me actually put the decimal form of that. Negative 6 divided by 800. So 200 is my x, 18 is my y. Let's distribute that. Negative 0.0075 times 200. Negative 1.5. Let's add the 18 to both sides. And I get y equals negative 0.0075x plus 19.5. That's my prediction equation. If I'm with the temperatures at different depths, I could plug into that equation. C says, hey, use your prediction equation to find the missing value. All I'm going to do is plug that into my calculator. So negative 0.0075, plug in 2500, sub that in, plus 19.5. And I get about 0.75. For me, based on my prediction equation, it's almost 0 degrees at 2500 meters. So that's how you do prediction equation, using data, doing it all by hand. Next, let's talk more about the regression line and what it means. And then we'll talk about how to do this all in a calculator. Linear regression. The way we do it here by hand, if you could probably tell, it's not the most scientific method. There's lots of different answers. We want to bring some science and technology into this. What we do is we use a regression line, which is what we use our calculator for. And it does the line of best fit for us and uses complex calculations to find the distance between each point is at the minimum. On your calculator, let's bring mine up right here. The way we get to that is this. I'm going to go stat, calculate, and there's all these regressions right here. If you scroll down, there's linear, quadratic, cubic. We're going to use the linear regression in this one. There's actually regressions for lots of different types of lines. That's a regression line. It uses a calculator to find the line of best fit as best possible. How about, what's this correlation coefficient? The R is how good is your correlation. When we draw a little line right here, the line of best fit, we have a line that goes through it, that's have a different R value. The way that works is we go from -1 to 0 all the way to 1. 0 is no correlation. That's when you get that scatter plots all over the place. So when R is 0, no correlation. When R is 1, that means positive. This is like a perfect positive. That means it's a straight line. So it's 100% correlation. Sometimes we don't get that. Sometimes we have a little bit less. It's going like this, but still going up. Then that'll be R like 0.85. The closer to 1 you are, the more positive correlation is, the stronger the correlation is. If you get an R that's 0.3, it's a weak positive. It's going up, but it's very weak. And likewise, when you go other side, when it's a -1. -1's a super strong negative. It's a straight line going down. But if you have ones that are going like this, that's strong, but it's not a perfect line. It might be a -0.85 or something. That's what the R does. R tells you how good of a correlation. How do you find your R? A couple steps. First, on your calculator, let's go to mode. If you go to the bottom, there's this thing called stat diagnostics. Now, for the life of me, I can't understand why the default is off. So this is how you find your R. We're going to turn this thing on. When we do a linear regression line, when we do one of these, they'll give us an R value, and that'll tell you how strong our correlation is. The best way to do this is by example. So let's go and do an example. Actually, let's go to the one I skipped up here. Let's do this one. Let's do it on the calculator. So this one says, I can scroll down a bit. The table shows the mean selling price of new privately owned single-family homes for 6 consecutive years. Make a scatter plot of line of best fit and describe the correlation. First thing I do is put all this data into my calculator. We're going to do that by pressing the stat button first. There's our stat button. Hit that button, and then you get to edit. It brings to this page right here. You should have L1, L2, L3. If you're missing one, something could happen. You might have hit delete on accident. If I press delete here, there goes my L1. It's gone now. Delete L5. Well, there goes L5. So that could happen. Don't ever press delete up here with these values because you lose them all. And something in fear, we can get them back. If I want to get them back, go back to my stat and go all the way to number 5, setup editor. It'll reset everything basically. Now if you go back to stat edit, all my L1s are back. Let's go back to actually playing the data. The year, we're going to let that be L1. So I'm just going to go and type in 0, 1, 2, 3, 4, 5. I'm going to do L2, put it in 154.5, 166.4, 207, 7, there you go, 0.7, and 273. All my data is in there. Oh, they want to draw a scatter plot. So let's do this. Now, if you want to draw a scatter plot, if you look at your calculator, it says stat plots. Let's hit that. It's in blue. I hit the second button first. It brings us to this page. I want to go to my plots and I'm going to turn it on. Let's click on the plots. And then see how it's, right now it's dark and off, but it's highlighting that. So if I press enter, it switches to on. If You go down here, plot that you want. We want a scatter plot, that's fine. Scroll down. Do you want your X list to be L1? That's what we had. Yeah, we're good. And your L2 list to be Y. Yeah, that's what we had. We're good. Then this is what mark you want them to use. The default's fine. We're going to hit graph, and I see nothing. A couple reasons why I see nothing. One, if you look at my data, it goes from 0 to 5, but my price here goes from 150 to 23. This right here is negative 10 to 10. I don't see anything right now. I want to see my data. There's a couple ways to do it. Way one is fix our window. Right now my window says it's from negative 10 to 10 and negative 10 to 10 on my Y. With my window here, let's change my X. I want to go from 0 to 5. So I'm just going to go for my X min. That's the lowest X value you want. And the highest X value you want is 5. Scale is what you want to count, but I just always leave it 1. My Y min, let's go 0. I'm going to go 0 here. What's my Y max? I see 273. So let's go all the way to 300. Let's round up. The highest I want to see is 300. X-red, how much resolution do you want? 1's fine. And that's if we're going to leave it alone. I've hit a graph. Yeah, get a little graph looks like that. Describe the correlation. Looks positive to me. It's a positive correlation. If I want to draw a line, it doesn't have to be perfect. Let's try to match it. It looks something like this. It's going like this. Let's talk about how to write a prediction equation. Let's do the prediction equation. For the prediction equation, you got to get out of this. Let's go second quit. Let's go to the regression line I showed you earlier. I'm going to go stat, calculator, go down to linear regression. And here it says, do you want the X list L1? Yes. L2 for a Y? Yes. Frequency list, that's only if you have a frequency. And we don't have a frequency here. I'll leave that alone. Store requests. We'll talk about this later. I'll leave it alone. Let's go to calculate. And then it calculates for you, and then look at what it gives you. It gives you an equation, y equals ax plus b. That's a linear equation. And it tells you what the values are. Let's just round it. 23.1, and b is 144. 23.1 x plus 144 for my b. That's my prediction equation. Look at our R there. See how it's 0.97? That's really strong. Closer to 1, the stronger you are. That's a really strong R. It's a really strong correlation. So we have that, my prediction equation. Let's do the next one. Predict the selling price of a new home in year 8. Years were X. We're just going to plug in 8 here. We have a calculator. Let's do that. 23.1 times 8 plus 144. So in 8 years, selling price of a home will be $32,328.8 thousand. How accurate does your prediction appear to be? Fairly accurate. Remember, our R was huge. Our R was 0.95. was a solid R. I'd say it's pretty accurate. That's how you find the regression equation using a calculator. We'll do a couple more, but just to remind you guys, by hand, you're going to do a prediction equation. You're going to plot it by hand, draw a line best fit as best you can, find 2 points that cross nicely, and then use a point slope equation to find the prediction equation. The calculator, we're going to type the data into our calculator, and then we'll do a linear regression to find the prediction equation. Let's do another one. The table at the right shows the percent of sales that were made in music stores in the United States in the period of 1999 through 2008. Use a graphing calculator to make a scatter plot of the data, find the graph line regression, and then use a function to predict the sales in 2018. We're going to put all this data into our calculator. I'm going to go stat, edit. Now, if I want to delete data, a couple of things. So if you want to clear the whole column, just put clear for L1. And that whole column's gone. If you made a mistake on one of the rows, there you can put delete. And it'll get rid of that one thing. You don't want to put delete up here. If you press delete up here, then it just goes away. You have to do setup editor to get it back. When you do the whole column, just put clear. And we're going to type all this stuff back in again. Remember, you could pause your screen if you want to catch up and type all your stuff in. Next, let's do a scatter plot. My scatter plot's actually already on, so I don't have to change anything. It's already on. You want to make sure you turn it off at some point. I don't see anything. Why? Because now my values are all changed. I can go in my window and make my X min 1999, my X max that 2008. There's actually an easier way. Another way of doing this is if you hit the zoom button. So here's your zoom button. If you scroll down to the bottom, there's one that is zoom stat. That zooms to try to fit this as best it can. Let's hit that one, zoom 9. And then it does the graph for you. As you can see in this case, that's the negative correlation. It's going down. If they want me to draw it, it's a sketch. You don't have to be perfect. Just give me an idea what it looks like. There you go. Percent music sales in music stores is going down rapidly. Use a graphic calculator to make a scatter plot. Done. Let's find a graph and line regression. For that, I'll go back to our stat. Go to calculator. Let's go to linear regression. Have L1, L2. I don't have a frequency list. Let's talk about store requests. So they're saying, hey, do you want to plug that equation you find into your Y so you can graph it? And you don't have to. But if you want to, all you have to do here is put Y1. So you plug it into here, basically. I can hit Y1. How do I do that? Linear regression. Go down to there. I got to find an equation for that. So the easiest way to do it is you press alpha F4. These are the shortcut keys. So you bring up Y1, Y2, all this stuff. You want to plug in for Y1. Calculate. So there's my equation. x plus b to give me what the a is. It's negative 1.4. Give me what the b is. Negative my r. Look at my r this time. Negative 8.4. It's a strong negative. It's not as strong as last time, but still a strong negative. I have my equation. Y equals negative 1x plus 2009-26. Let's talk about what each thing means. X is year, and y is percent of sales. Let's talk about what slope means. We haven't talked about this yet. What slope means here. Slope is a ratio. Negative 1.4 is y over x. And my y here is sales percent, and my x here is years. What that's telling me is that every year it's going down another percent. Every year I'm going down negative 1.4 sales percent per year. Anytime you see the line, just add a per. Let's go back to my graph. And see that line there? That's what happens when we put the y1 in. It draws the line of best fit for you so you can see it. If you go to y equals, that's the equation. They plug it all in for you. Anyway, they want me to predict the sales in the year 2018. So all we gotta do is sub that in. Y is gonna equal negative 1.4 times 2018 plus 2926. Plug that into our calculator. And I got 15.4. Actually, let me show you how I did it. One way of doing your calculus of 2018, if you press second calculator, it lets you type in a value. Like let's type in 2004. It'll tell you, oh, in 2004 it's 36%. One second calculator, 2018. Now it said error, and the reason it says error is because my window doesn't go down to 2018. My window only goes to 2008. But what I did was like expand it to 2020. So now my graph goes all the way to 2020. Now if I went second calculator and put value, now I can put 2018, and it gives me about 15.8%. So that's how you do on your calculator. Anyway, that's the lesson.